All right, so here's the second part of our lesson in proof using coordinate geometry. Again, I split the video up in two parts because I realized if I left it all as one video, it was going to take a really long time, and I didn't want to bore you all with an almost hour-long video, so I split it into two. You can watch both pieces, um, or however you want to do it. Okay. So we're still proving things. So this time I've given you a square FGHI, and we're trying to prove that FH is congruent to GI. So look at our picture. FH is congruent to GI. That's what we're trying to prove. Okay. This is a property of a square. It's also a property of a rectangle. And a square is always a rectangle. So that's why this works for squares. Okay. So we've got some coordinates here that I've given you. And we're trying to prove their congruence. So we're going to use the distance formula between FH and GI. And that if they're the same length, then we've done it right. So I'll give you the distance formula again. So we're going to use that. And it says usually to start with the second one. So the point that's listed second here is going to be H. So I'm going to start there. I'm going to put my big square root. The H of the X of H is A, and the X of F is 0. So we'll do A subtract 0 squared plus the Y of H. That's the second one. Subtract the Y of the first one, so it'd be F. So Y2 is 0, subtract Y1, which is A. So 0 minus A squared. Clean this up. A minus 0 is just A. So we're left with A squared plus 0 minus A is negative A squared. Now, we have to clean this up further, this part. Negative A squared means negative A times negative A, which is A squared again. So we have 2A squareds. And so we can write 2A squared. That's how long FH is. All right, now let's look at GI. So I comes second. We'll start with that. The X of I subtract the X of G. So 0 minus A squared plus the Y of I subtract the Y of G. So another 0 minus A squared. And then we said earlier 0 minus A is negative A in parentheses squared plus another one. And then before we said that negative A to the second power was just another A squared. So let's change those. And then there's two of them, so we write it like this. And then what we can do is A squared, the square root of it is perfect. Okay. If you remember from when you were freshmen, you took data and measurement, you learned about square roots. Okay. If this exponent is 2, then the square root of that is going to be A, and then we'll leave the square root of 2 because we can't do anything with it. And I'll simplify the other one. Now this additional step, you could make a determination from here, but I wanted to go ahead and do that just so you could see it. Compare the lengths. So FH is that length, GI is that length. So we can say FH equals GI, and then we know that if things are equal, they're congruent. So FH is congruent to GI. There we go. I do that one. And the last one. Right. So now, instead of proving just a particular property of one quadrilateral, what I've done is, and there's a couple more like this, we've got one quadrilateral. So in this instance, we have MNPO is a rectangle. So MNPO is a rectangle. And then I've told you that we've got midpoints, T, W, V, and U on each side. And I went ahead and connected them. We want to prove that this inside polygon, TWVU, is a rhombus. Okay? I've given you the coordinates to use and a game plan, so we're able to follow it. But you remember what a rhombus is first. So a rhombus, remember, we know it has 4 congruent sides, but it's all, what is it? The more basic version of it. Remember, the definition we gave was that it's a parallelogram. So this is a parallelogram with 4 congruent sides. So I want you to look at a game plan for our proof here, okay? So first thing we're going to do is we're going to use the midpoint formula to find the coordinates of each midpoint. Then we're going to find the slope of the sides TW, WV, VU, and UT. We got to find those slopes first, and then we'll compare it for number 3. We have to do that first because we have to show that it's a parallelogram first. Okay, you can't jump to the congruent thing without doing this first. You have to prove it's a parallelogram. Then we jump to using the distance formula to find the length of those sides. And if those are all the same, then it's a rhombus. Okay, so this one is a little bit longer, but it's not very hard. All right, so let's do the midpoint formula for T. So look where T is at. T is in between M and O, so we're going to use M and O for our points. I can read M and O. So add the 2 x's, the x of M plus the x of O, divide 2, the y of M plus the y of O, divide 2. And if you simplify everything in there appropriately, you'll get that T is at 0b. All right? W. W is between M and N, so we'll use M and N. 0 plus 2a over M, the y of M is 2b. Whoops. The y of M plus the y of N, all divide 2. If you divide everything out appropriately, 0 plus 2a is 2a over 2, so we get a. 2b plus 2b is going to be 4b. I'm going to write that over here so you can see it. So we have 4b on top over 2. 4 divided 2 is 2b. Now we want v. V is in between n and p. So the x of n plus the x of p, divide 2. the y of n plus the y of p, divide 2. This section is going to work just like this one. So you should end back up at 2a, and then that's going to turn into just b. U is between O and P, and so 2a plus 0 divide 2, 0 plus 0 divide 2. This should turn into A0. Okay? Now we have coordinates for all of these points right here, T, W, V, and U. Now we use these all the time. Okay? So let's find the slope of all these sides. I'm not going to have a lot of room, so let me do this. Let's scoot that up just a little bit. There we go. All right, so slope of TW. Now, in case you forgot, slope is y2 minus y1 over x2 minus x1. Right? So start with W. The y of W, subtract the y of T over the x of W, subtract the x of T. Simplify that. 2b subtract b is b. A minus 0 is A. Right? And we'll just keep going. Slope of WB. Start with the y. The y of B, subtract the B, good Lord, my letters are getting mixed up, sorry. The y of V, subtract the y of W, over the x of V, subtract the x of W. And let's simplify that. We get negative B over A. Slope of VU, 0 minus B over A minus 2A. That's negative B over negative A, which reduces to B over A. And then the slope of UT. So B minus 0 over 0 minus A. We get B over negative A, or negative B over A. The negative's on the bottom. I just slid it up to the top for my preference. All right? So I've done step 1, done step 2. Step 3 is to compare the slopes of each side. So notice that 2 pairs of slopes are the same. We've got the slope of TW is B over A, and the slope of VU is B over A. Look at your picture. The slope of TW and the slope of UV. They're the same slope. Now look at the slope of WV and the slope of UT. They are both negative B over A. So we can say that opposite sides have the same slope. So TWVU is a p-gram. Okay? Could it be a rectangle? Well, if it were a rectangle, the slopes of the sides that meet, so here's what I'm saying. The side TW and UT. if this were a rectangle, this angle would have to be 90 degrees, which means that those slopes would have to be perpendicular slopes. And perpendicular slopes are opposite reciprocals, meaning you have a fraction, you flip it over, and you change the sign. So here's what I'm saying. Look at TW. It is B over A. UT was negative B over A. It's got the opposite part right. It's flipped the sign, but you haven't flipped the fraction. Okay, so it's not a rectangle. So we also have to say that TWVU is not a rectangle. Now, then part 3. So I have to use the distance formula to find TW, WV, VU, and UT. So TW equals my distance, square root. So remember distance, you start with the second one. So x2, because w is second, so use its x first. Subtract 0 squared plus the y of w, subtract the y of t. Simplify. A subtract 0 is just a squared plus 2b subtract b, that's b squared. All right, WV on the length of it. Start with v, so the x of v, subtract the x of w, the y of v, subtract the y of w. Two a minus a is another a squared, plus b minus 2b is actually another negative b. But remember, we talked about how this works out earlier. This is going to turn into positive, so we're going to write that. All right, keep going. Start with u. A subtract 2a squared plus 0 minus b squared. This will give us negative a squared plus another negative b squared. We've talked about how to deal with the negatives. So we know that turns into a squared plus b squared. All right, and now ut. Let me separate this off right here. There we go. I don't want to write over it. All right, ut, start with t, because it was second. So 0 subtract a squared plus b subtract 0 squared. That's going to give us negative a squared plus another b squared, which we know that's going to turn positive. All right, so look at the lengths of all our sides we just found, okay? Square root of a squared plus b squared. Square root a squared plus b squared. Square root a squared plus b squared. Square root a squared plus b squared. Every side has the same length, right? So I'm going to come down here and write this because I'm running out of room. So TW equals WV equals VU equals UT. All those sides were the same length. So TWVU is a rhombus. Oops, you can't see that. is a rhombus by definition. Okay, so I know these are kind of long. They take a little bit of time, but if you just take your time and go slowly, you won't screw it up. Okay? Look at how I followed my game plan. I was nice and gave you this game plan, okay? I want to make sure you know how to do this and can do it correctly. So that's why I gave you these steps to follow. Notice what order I went in that order. So I found the coordinates of all the midpoints using the midpoint formula. Then I found the slope of each side, did my comparison of the slopes. Then I found all the lengths of the sides using the distance formula. Then I made my comparison. And then my final statement, it's a rhombus. Okay, that's the formula you're going to have to follow on your homework. I know there's at least one problem like this. All right, that's the end of this second video. So I'm only giving you 4 homework problems to do, okay, because these take a little bit of time, and I want to make sure that you are not bogged down with a bunch trying to get a bunch of stuff done, okay? There's just 4, and they look a lot like these notes, so use these notes as a guide, okay? And if you run into any trouble, just let me know.